All right, so this first one is all about end behavior, right? We can't see what's happening in between. We can just see what their arms are doing at the end. So for x cubed plus x minus x to the fourth, the leading coefficient and the degree of the highest degree term, it's a negative leading coefficient, and the highest degree is 4. So then if we look at our notes on end behavior, we have a negative leading coefficient and an even degree because it's 4. So that means we're looking at down and down. So the arms are going to be like that, down. And then we look at the next one. We're looking at a leading coefficient of 6, which is positive, and then the degree of this polynomial is going to be 1, 2, 3, 4, right? This one's 2, 3, 4. So it's a fourth degree again, but this is a positive leading coefficient. So that means we're looking at positive leading coefficient, even degree, so both of them are facing the same direction and they're both going up. And then the last one is, let's see, ninth degree polynomial with a positive leading coefficient. So then we look over here, we have ninth is odd degree, positive leading coefficient, so we're looking at that. So then overall, we're going to have that. All right, and the next one, we've got, oh, this one. So the first thing I'm going to do is I'm going to slide each stick figure to one of the 4 zeros. We have a 0 at positive 6 is the first one. It's on the far right. Then we have one at positive 2. And then we have one at negative 4. And then we have one at negative 7. So now we need to see what their arms are doing at each of these spots. So just a quick look at this on a whiteboard. So let's look at x plus 7 first. So since it's x plus 7 and the multiplicity is 1, right? It's just going to be straight through the point, but it could be going up and it could be going down. We don't know that. And the only way we know where it's coming from is based on the end behavior. So that means we're going to look here and we're going to say we need to know the degree of the polynomial, and we know it's a positive leading coefficient because there is no coefficient. But the degree of the polynomial is going to be, let's see, we've got 1 plus 2 is 3, plus 1 is 4, plus 3 more is 7. So we've got a 7th degree polynomial. So then we're going to look at our notes and we're going to say, well, it's a 7th degree, so it's odd degree, positive leading coefficient. So we're starting down here and we're going to end up. So looking back here, now we know that we're going through this point like that because we're starting, because we know it's just straight through because this is a first degree according to our rules about multiplicities. This one's also first degree. And the end behavior tells us we start down and we're moving up. And then the next one, we don't have to check end behavior on this because we know we're already up here. So that means when we go through this point, we're going to have to be going down. But this is squared, so it's actually going to be a bounce back, right? Anything to an even power bounces back. And then this one is a first power, so that means it's a straight through. Again, we're already above the x-axis, so that means we're going to have to go back down through it to get to the 0. And then now we're at 6, and it's a 3rd degree, which means it's a squiggle, right? And since we're below the x-axis, we're going up through it, so it's going to be something like that. And with what we've learned, we don't actually know how high these go, so you can kind of just guess that part. But you didn't actually have to graph this one. This was just doing the arms of the disco guys, but this ends up looking like this. So we've got straight through, then the bounce back because it's 2nd degree, then back straight through because it's 1st degree, and then squiggle up because it's 3rd degree. And that matches what we had for end behavior, right? It starts below the x-axis and it ends above the x-axis. And so they'll even give us a little preview of it. Same thing here, so I'm going to go through it a little bit faster. Let's see, the first one is x minus 5, so that's going to be a 0 at 5. This one's going to be 0 at 1 because it's x minus 1. This will be a 0 at -2 because it's x plus 2, and this will be a 0 at -5 because it's x plus 5. So now we just need to figure out what the degree and the coefficient is. There is no coefficient, so it's 1, it's positive. Then our degree is going to be 2, 4, plus 3 is 7, plus 3 more is 10. So it's an even degree, and that means they're going to both be below the x-axis or both above. We got an even degree and a positive leading coefficient, so that means we're looking at both above, like that. So that means we really only need to use that for the first one, right? Because then we know we're starting above the x-axis. We're starting above the x-axis, and then it's a second degree one, so actually we're going to bounce at that spot. So we're starting up here, and then we're going to hit this 0 and bounce up. And then the next one is also second degree, so we're going to come back down and bounce up again because it's another even degree multiplicity. The next one's third degree. So third degree polynomials, and again, I guess I haven't showed you this in this video, so I'll just point out multiplicity is here. Third degree polynomials are anything of a odd multiplicity other than 1 does the squiggle through like this. If it's 1, it goes straight through, and if it's even, it bounces. So the next one is third degree. We're starting above the x-axis, and we're going downwards through it, so it's going to be a squiggle down. And then this one is going to be third degree, but since we're below the x-axis and we're going up now because we're down, then we're going to go back up, so we have to squiggle up. And that should be it. Should do it. So for this one, we just need to figure out what those number symbols are, or hashtags. But basically what we're going to do is just basically these are zeros, right? X plus whatever this 0 is and x minus whatever this 0 is, and then it'll match. So we've got x plus 5 is this 0. This is plus 3. So that first one's going to be plus 3. Right? 3 is between 2 and 4, -3. Then we're going up, and then we're going to go back down through x equals 1 as the 0. So x minus 1 is the factor for x equals 1. And then the last one comes back up at 5. So if this is x minus 5, then we should be golden. And yep, it matches, fills it in on top. So we'll go to the next one. Now we're trying to figure out what the leading coefficient is. So if you first we can figure out if it's positive or negative, counting the degrees. It's for 1 degree, 2, 3, 4, and 5. So it's a 5th degree polynomial. Positive leading coefficient. Well, I guess we can choose the leading coefficient. 5th degree polynomial. So if we want it to start above the x-axis up here and go down through it and end going downward, then we are going to need a negative leading coefficient, because we've got right here, we got the odd degree. We want to start up and go down. So we need the negative leading coefficient. So that tells us the first thing is that this number is negative. And then now just looking at it, that tells us that we're going to want to make it taller. So do we want to go bigger than 1? No, 2 is too big. 1's too small because it goes, so it's going to be somewhere between 1 and 2. So I'm just going to pick 1.5 as my first guess, and that was it. So the next one, we're going to write the function for this one. So the first, and it tells us what the coefficient is, so we don't have to worry about that. So then basically we just need to do the zeros, right? So f of x equals, and then we're going to find the zeros. We've got one here at -5, and we've got one here at +1, and we've got one here at 5. So some of these are going to be different degrees, so we're not done yet, but x plus 5 times x minus 1 times x minus 5. Now, obviously, this didn't work, so we've got to change something. It's going to be the multiplicities, right? So this one's straight through, so that's going to be a first degree one, this first one on the left here. And then this one bounces back, so it has to be an even degree. This could be 2, it could be 4. We don't actually know. And then this one's a first degree because it goes straight through. But we know A, so we can just kind of test out ones. We could try 4, right? It's not 4, it's going to be 2. And there it goes. So now we want to write an equation for this one. Same thing, they give us the coefficient, so we just need to figure out what the zeros are. So this one, it looks a little tricky on the left side. It might have helped to zoom in here. Using that plus sign on the right. So we see we've got a 0 at -3, so this is going to be x plus 3. And then we've got another one close by at -2, so it's going to be x plus 2. And then we've got our last one at +3, so we're going to have an x minus 3. So then, obviously, we need to make some changes. Oh, there's another one, sorry. And then there's one at x minus 5. Dangers of zooming in. All right, so now it looks like it's lining up well. We just need to change the multiplicity of one of these, right? This one goes straight through, it seems, but this one bounces back, right? So that's going to be an even one. Let's make it 2 for now and just see what happens. Oh, and it says use a equals 2. So that means our coefficient's going to be 2. Oh, and it matched. So then we're good. On to the next one. This one says your function should have degree 4. So that means it's going to have the multiplicities are all going to add up to 4. Have roots at -4, -2, and 3. So this is going to be x plus 4 times x plus 2 times x minus 3. So that satisfies my roots, right? But I need 4th degree. This is 3rd degree. 1, 2, 3. So one of these has to be squared because then the multiplicities will all add up to 4. So I'm just going to square this one. It may not matter which one we choose. So now we want approach -infinity as x approaches -infinity. So then we're going to look at the end behavior, right? So we've got, we can look at the bottom parts of these for this part. So we've got approaches -infinity as x approaches -infinity. So that one works. That one does not work. That one works. So, and that one works. So it's going to be one of these 3. Or not this one. So it's going to be either one of these. And then we'll look at the second one. Approach -infinity as x approaches +infinity. So as x approaches +infinity, y approaches -infinity. As x approaches -infinity, y approaches -infinity. So basically what it's saying is we want it to be an upside down. We want them both to be pointing downward. So, and you can kind of read that. Approach -infinity as x approaches -infinity. Approach -infinity as x approaches +infinity. You could almost just figure that out without looking at the end behavior chart. But we do know that that tells us what our coefficient needs to be. In this case, we need a negative coefficient. So that'll do. You could put squared on any of these. You can put any number here. There are a lot of correct answers for this one. These ones have specific answers because they include a point. So for starters, it's 3rd degree, and then the roots are going to be at -2. So this is going to be x plus 2 times x plus 1 times x minus 2. I'm just taking the roots and turning them into factors. And then it's got to be 3rd degree. This is 3rd degree, so we don't need to square any of these. It's good as it is. But it doesn't include the 0.04. This is the 0.04 right here. X equals 0, y equals 4, right? Doesn't include that point, so we need to make it include that point. And I think for starters, like I can see actually it's going through this right here. I might even just try a negative. But I'm actually going to show you how to solve for it. So we've got, this is our equation. So far, this is what our equation is, but this doesn't work, right? So that means we're going to have to change it in some way without changing the factors. Well, we can put a coefficient on it, and that's what we're going to do. It's the only other thing we've done, so it was kind of like that was the next step in figuring it out. But you need to put a coefficient on it to make it negative or upside down. And then we also know a point, right? So we can actually plug that point in. We can say it was 0, 4, so that means 4 equals a times 0 plus 2. 0 plus 1, 0 minus 2. So then 4 equals 2 times 1 is 2, times negative 2 is negative 4, so this is going to be negative 4a. Divide both sides by negative 4, and you get negative 1. So we could just put a negative sign in front of it, and it should just flip over. And that's what we need. So that's how you do that one. And this next one, but this one's a little different because we have some multiplicities to work with. So we've got f of x equals, and then let's see, we've got x plus 3 times x plus 2, or x minus 2, times x minus 4 squared times x minus 5. Again, I just did that by looking at the zeros right here. Half degree 5, 1, 2, 3, 4, 5. So we're good. So the only thing we need to add is the a value, and we're going to solve for that just like we did on the last one by plugging in this point. So once again, we just plug in our y value and then 0 for x. It's easy to plug in 0 for x because then you just multiply all the I guess they're the negatives of the roots. Oh, these aren't x's, these are zeros. The zeros kind of just go away. Oh, I forgot my variable. So I put that a there for my coefficient. Now this ends up equaling 480a. 15 equals 480a. We divide both sides by 480. So a equals 15 over 480. Let's test that. 15 divided by 480. No, it didn't work. 15 divided by 480. All right, and then that should work, right? We've got the point 015. I guess that's the only thing we need to check because we already checked our zeros. And bingo. Got it. All right, and that's it.